In this video, we're going to be talking about graphs, specifically those of motion. We're going to compare displacement versus time graphs, velocity versus time graphs, and acceleration versus time graphs. Now turn to your packet where it talks about graphs of motion compared. You'll see this very chart in there. We're going to fill it out today, and in another subsequent video, we will have another video about the graphs themselves, looking at the graphs and interpreting those themselves. For now, what we're going to do is we are going to first talk about the displacement versus time graph. How much space or how much distance you went in a certain amount of time. Then we're going to move to velocity versus time, how fast you're going in a certain amount of time, and acceleration versus time, how fast are you speeding up. So the first graph first thing we're going to go into is the y-intercept. The y-intercept is the starting position or the initial displacement, where you're starting. Are you starting at the starting line at 0, or are you starting somewhere else? You could have a head start, or maybe you're behind the 0 point. It changes depending on where that y-intercept is. The slope of the line, though, does actually mean something. It means the velocity. So in a distance versus time graph, the slope means the velocity. If it's a positive slope, it means it is going in the positive direction. You are moving in the positive direction. You're speeding up in the positive move. Negative means you're going in a negative direction. You're going backwards. And if zero slope means you're not moving. So this is your velocities. Now, if you have a straight line, it means you are going at a constant velocity. You are going at a specific 60 miles an hour, 12 meters per second. A curved line, on the other hand, means that you're changing that velocity. Your velocity is either increasing or decreasing. You're stepping on the accelerator, or stepping on the brake. You're speeding up or slowing down. Now, this one there is no such thing as the area under the curve. We're not going to go into that one. That doesn't really exist. But if you have two lines and their curves are the same, that means that they have the same velocities. Now, if they have a very steep line, it means that they're going very, very quickly. If they have a shallow line, it means they're going very slowly. But if they're the same lines that parallel to each other, they're going to mean that they have the same velocity. You know when they're stopped is when the horizontal line or has zero line. Now, we can look at it right here. Zero slope, and up here it's not moving, has a zero slope again. Uniform acceleration is when you have a curved line, meaning you're speeding up. You're hitting the accelerator or the brake. Now, finish writing these down. We're going to move over to now the velocity line versus the velocity versus time line. The y-intercept for a velocity versus time graph is the initial velocity. So it's what is the speed initially? Is it at 0, which it could be, or are you starting off at 60 miles an hour? If it has a slope, this time it's not instantaneous velocity, but it's an instantaneous acceleration. How fast are you speeding up? If it has a positive slope, it means it has a positive acceleration. If it's a negative slope, it means it has a negative acceleration. Zero slope means your constant velocity, cruise control. Not speeding up, not slowing down. Straight curves, a straight velocity versus time means a constant acceleration, meaning you're going at a constant straight up. A curved line is a changing acceleration, and we'll go into those later. They're known as jerks. Under the curved, if we get the area of under the curve, and we'll look at these later in the next video, but it represents the displacement. Curves also coincide with objects having the same acceleration. So if you have two lines, there's the accelerations. You know it's stopped when it crosses the t-axis or the zero marked axis. And you have a uniform acceleration when it's a straight line. Now we're going to move over to the acceleration time graph. The initial acceleration is the y-intercept. Again, if you notice, there's a kind of a theme going on. Now, let's moving on to this next one. This next one, we're going to cross out. The slope of the acceleration, if it has a slope, it's known as a jerk. Now, jerks we don't deal with. We're not going to deal with any acceleration versus time graphs that have lines. So if you have an acceleration versus time graph and it has a line in it, we won't deal with it. Those are jerks, and we don't deal with jerks. Jerks are mean. They mean something that's really, really hard to understand. On the other hand, if it has a zero slope, when it's just flat, so there's your zero line and it's going along and it's nice and flat, that means it's a constant acceleration. We will deal with those. Again, straight lines, that's a jerk. And curved lines, well, that's a super jerk. And we don't deal with super jerks. And in fact, they've come up with names of them. We call them snap is a changing curve. A crackle is beyond that, and a pop is the next. Don't know why they named it that, but they actually did name that. Now, the area under that curve, if we were to look at the area underneath here, these curves here, and calculate that triangle there, that would be the average velocity, how fast it went. The curves coincide with objects having the same jerk. Again, we're not going to deal with jerks. Now, we know it can't. When it's stopped is very difficult to tell. We don't know if it's stopped because if it's on a axis like this and it's along the line here, well, we can either tell it's not speeding up or not slowing down, but we don't know if it's stopped. It could be either stopped or moving at a constant velocity. We cannot tell. And then lastly, the uniform acceleration happens when it's a straight line. Again, very similar to this one up here. Now we can look at this and we can actually see we have our different types of graphs. Now if we want, we can actually look at distance or displacement, velocity, and acceleration. If we wanted to go from displacement to velocity, we look at the slope. If we wanted to go down again from velocity to acceleration, we look at the slope again. But if we wanted to go back up, that is acceleration. Now, calculus students will know different words. They call this derivatives, and they call this integrals. But for the most of you, you can ignore that fact. I hope this was helpful. If you have any more questions, go talk to your teacher.